Okay, so I passed out a handout for you guys to look at while I do the rest of the lesson. Okay, so we were talking about linear function, and here's a bunch of examples of linear functions, okay? So you've got a cross, you've got these diagonal ones, and remember the one that I said that is not a function is anything that goes up and down. So if it looks like this is not a linear function, okay? Now, so linear meant line, it makes a line. Here are some other types of functions that you can get, okay? You have one that makes the shape of a parabola, and you have all of these that curve like this, and they are different types of functions, okay? So not all functions are straight lines, okay? So an exponential function is an equation that has an exponent in it, okay? So if you have something like x squared equals y. Remember this little number right there is an exponent.
I can't see it. I'm trying to be cool here, it's just not working.
Well, I thought the green would work since these lines are green.
Sort of, just not real well. But okay, just keep going. Keep going.
So x squared equals
I swear,
y.
Dr. Cohen, it didn't mean for that to happen.
Okay, so anything that goes up and down is a nonlinear, or is not a linear function. These create exponential functions, but the only two that we're going to worry about are the ones that are x squared and x to the third. Okay, those are x to the second and x cubed. Okay, so if you would scroll up for me, please. Keep going.
Is that right?
Yeah. So you have some more pictures of what an
This is very
exponential function looks like.
Really good
Which
technology
are
here.
curved, and again linear, which makes straight lines. Okay, so the way to check if something graph is a function is to use what's called the pencil test. So what you would do is take your pencil on your handout, okay, and you place it over the graph straight up and down like this. So we'll pretend this is a pencil, and you'll keep going. Is there any place on the graph where your pencil touched the line more than one time? Okay? If it doesn't touch the line more than once, what you have is a function. Okay? So this is an exponential function, and this one again is linear. It only touches one place on the line each time. Now that special function that I said that is a line and doesn't work, the one where it goes up and down like this, if I were to use the pencil test on it to go across, right there it's touching a whole bunch of points on that line. So because it's touching more than one point, it cannot be considered a function. Okay? And part of the reason it can't be a function is because it doesn't have a slope. So if you think about a mountain, something like that, this has a slope, like you're going up like a mountain, the side of a mountain. When it's straight up and down, there's no slope. If you had one that has a line like this, you just have a flat line. It still has slope, but it's not going anywhere, okay? It's staying stagnant. And the reason that's important is because when you use this math in the world of business and places like that, you tend to have and use these slopes or the way that these are going to predict trends and in things like business, okay? So slope shows the way that the function is going. So either the slope of the function is going positively or it's going negatively, or there is no slope. Businesses, again, use the information to predict the way the trends will go, just like the stock market and what we talked about earlier in our bell work with the stock market. To tell if a slope is positive, you're going to start from the left-hand side of the graph. And so from the part where you have drawn, so starting from the left side, and you're going to work all the way to the other end. Okay, so for both of these, when I start here, I go there. Where did I end up? I ended up going up. Okay, I ended up. So if I end up in the up position, that means my slope is positive. Okay, now if you did it the other way, can you move the computer up? No more. Right? So if you take this one, I start over here on my left, and I follow along the line, and where I ended up was down here at the bottom, or down. So if I move down, my slope is negative. Okay? Kind of like if you're going down a hill. Going down a mountain, you end up down here, your slope is negative. And then there's no slope. You have neither a positive or a negative slope if you have something that looks like this. Okay, straight line. All right. So now what I want you to do is to get into groups, and I want you to use the form that I handed out to you, and I want you to tell me if the function is positive or negative, and if it's linear or nonlinear.